Good evening, friends. As in the previous video, we have learned about the shared variables in Spark, which we have got broadcast variables and accumulator. As we learned that broadcast variables are those variables which are used to save the copy of data across all nodes. There's a concept of caching the data instead of creating multiple copies for each of the worker nodes shipped over the task. Instead of that, we just have the common data cached, serialized in each of the worker nodes. And then we learned about accumulator, that these variables are used to aggregate the information, like we are summing or doing a multiple products for the variables. So to aggregate the information through associative and commutative operations. We will learn about accumulator in more details. In this video, we will focus on broadcast variables. Let's go to the broadcast variables topic. So broadcast variables allow the programmer to keep a read-only variable cached on each machine rather than shipping a copy of it with tasks. So if you go to the diagram here, so here if we have got this driver program in which we have got a variable m, which only have to be like read-only copy spread across all the worker nodes. In that case, we can use the spark context.broadcast on that variable, which means that this variable would be using a very efficient broadcast algorithm, which will require minimum communication costs, and this would be cached across each of the worker node instead of sending a copy with each of the tasks. So this is what we are talking about. Spark attempts to distribute broadcast variables using efficient broadcast algorithms to reduce communication cost. And we have also learned that whatever the actions that we use, for example, map or reduce or count, whatever, so these are executed through a set of stages. What we meant by stages is that when we call this action method here, in that case, it will create a job, and all these jobs and all these tasks are split across various stages. And these stages of tasks would be submitted once they are ready. They will be submitted to the task scheduler, and this task scheduler would be launching all the tasks to across all the worker nodes via the cluster manager. So this is what we are talking about the stages here. So Spark automatically broadcasts the common data needed by tasks within each stage. And we also need to ensure one very, very important point is that the variable that the common data that we're talking about, that should be not mutable, which means that it should not be mutated across all the worker nodes. Otherwise, this will not work, because otherwise, if you are rebroadcasting that variable, then the new node will be having a new variable which is not same as the previous cached data which was broadcasted before. And another thing to note is that the data broadcast this way is cached in serialized form and deserialized before running each task. So if it is, so we should be assuring that whatever the broadcast variables we are trying to broadcast, that should be serializable. In Java, as we know that we have to implement serializable interface to make any variable, any object to be serialized. We have to ensure that. For example, if we are using a map or a list which already has implemented serializable, that should be fine. But if we are creating some custom object, it should be implementing serializable interface or externalizable interface, whatever. So only those data can be broadcasted, which can be serialized. And it also means that explicitly creating broadcast variables is only useful when tasks across multiple stages. Multiple stages need the same data, or when caching that data in serialized form is important. So this is something that we have to use this common data only when it is used across all the stages of the tasks. So let's take an example here. Suppose I have got this int as an int array containing 5 integers as an array, and we could denote it as m here. So we can create this as a broadcast variable by using the spark context dot broadcast, and we pass this integer array. This is our broadcast variable, which is an array of integers. And once we get this broadcast where we can get the actual the value, the broadcasted value, by calling this value method. So this is what we were talking about, that broadcast variable should not be modified, because once it is if it is able to modify it, then it will not work if the variable is shipped to a new node later. And once we are done with all those operations by using this common data, cache data, or the broadcast variable across all the executors, and if we want to release the resources, then we can call unpersist method. By using unpersist method, if the broadcast is used again afterward, it will be rebroadcasted. But if you want to completely release all the resources, that even after, even if we broadcast this again, it will not be rebroadcasted. In that case, we can use destroy method. So one thing important is that this can be resulting in a blocking operation. So if these methods do not block by default, but so suppose if we are running our Spark application and our main driver program has already completed. So if we are trying to release the resources using unpersist or destroy, and if we are not blocking it by default, then it cannot be released because our main program has already finished. Our main driver program has already finished. To make it blocking, we can also specify a blocking is equal to true as an argument to unpersist or destroy method, so that our main program or the driver program will only exit until it releases the resources, the broadcast variables. So enough of the theory now. In the next video, we will actually write a complete program to demonstrate what we have discussed today about the broadcast variables and how we are able to use these variables in a serialized form and then use it across all the executor nodes. Once we are done, we will see the examples for both unpersist as well as destroy method, both with blocking is equal to true and non-blocking. So see you all in the next video.